Diving in today with some more angles. What we're going to talk about is what is a transversal. A transversal is a line that intersects more than one line. So here, right now I have two lines, and these marks here mean they're parallel. So I'm going to name these lines. This is going to be line M, and this is going to be line L. So right now I'm telling you that M is parallel to L. This sign means parallel. And when you see it in a diagram, they'll look like this. These two lines, I'm going to intersect them with a transversal. A transversal is just a line that intersects more than one line, like such. Okay, we can call it T for transversal. With that transversal, we just created 8 angles. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8. So from our previous video, we could actually name or categorize some of these angles based on their positions. So if you remember, we had vertical angles. Vertical angles are where they share a vertex. So looking at the diagram, I could say angle 5 and angle 8 are vertical angles. So what that means is angle 5 and angle 8 are congruent, meaning they have the same angle measure. We could list all of them, might take us a minute, but we have 5 and 8, 7 and 6, 3 and 2, 1 and 4. So this is just an example of our vertical angles. Okay? We also have linear pairs. So if we look at our diagram, linear pairs are two angles that make a line. Well, 1 and 3 make the transversal. 1 and 2 make line L. So again, just an example, I could say angle 1 and angle 2. So if we add those together, they're going to equal 180 degrees. But we've got actually some more relationships that are pretty cool. So we're going to look at those right now. So first ones that we're going to look at, these ones are called corresponding angles. So corresponding angles. These angles, we're going to go like this, and we're going to say they're in the same position. So looking at my diagram, angles that are in the same position, 1 and 5, they're above the parallel line on the left side of the transversal. So 1 and 5 are corresponding angles. And because our two lines are parallel, we actually can now say the measure of angle 1 is congruent to the measure of angle 5. 1 and 5 are corresponding, and they're congruent because my lines are parallel. So if angle 1 was 110 degrees, that means angle 5 is 110 degrees. And because we know angle 1 and angle 2 are linear pairs, they have to add up to 180 degrees. I now know angle 2 is 70 degrees. If angle 2 is 70 degrees, its corresponding angle, angle 6, is also 70 degrees, which means it's supplementary with angle 5. Okay? These are all interlocked together. They work together. It's pretty cool. All right. Corresponding angles, they're in the same position. And because our lines are parallel, they are congruent. All right. The next one, their fancy names here, alternate exterior angles. Alternate exterior, it is what it is. Alternate, meaning they're on opposite sides of the transversal, and they're on the outside of the lines. So 1 and 8 are opposite exterior. This is on the left side, this is on the right, and they're on the outside of our lines. So 1 and 8 are alternate exterior angles. And because M is parallel to M, the measure of angle 1 is congruent to the measure of angle 8. Okay? Woo, we went to sleep. Are we still recording? I sure hope so. Okay. And we should be able to see that now if we look at some of these relationships. We know 1 is congruent to 5, so they're both 110. 5 and 8 are vertical angles, so it's also 110. So now we can see 1 and 8 are most certainly congruent. All right. The next one, similarly named, these are alternate interior angles. Interior means they are inside the parallel lines. So instead of being outside the parallel lines, they're inside the parallel lines, opposite side of the transversal. I feel like I'm doing some like, walk like an Egyptian. Walk like an Egyptian. Okay, sorry. Yeah, okay. Alternate interior angles. So alternate, they're on opposite sides, but they're inside our lines. So 5 and 4 are alternate interior angles. So would be 3 and 6. So the measure, sorry, I got ahead of myself. Because our lines are parallel, angle 3 and angle 6 are congruent. Again, these are just examples. We also know 4 and 5 are alternate interior angles. So again, let's take a look here. We know that 2 and 6 are 70 degrees because they're corresponding. 2 and 3 are also congruent because they're vertical angles. And now we see 3 and 6 are congruent because they're alternate interior. Okay? Okay, one more set here and we'll call this good. Our last thing we're going to look at, these are called same side interior. We might also hear these called consecutive interior angles. So as long as we recognize the name, we should be okay. Same side interior or consecutive interior. What that means is they're on the same side of the transversal inside the parallel lines. So 3 and 5 are same side interior angles. 4 and 6 are inside or same side interior angles. And what do we notice about 3 and 5? They are supplementary. They add up to 180 degrees. And that's because our lines are parallel. So the measure of angle 3 plus the measure of angle 5 equals 180 degrees. These are supplementary. It's a lot of information there. We're going to go ahead and use those in class. Take a look at the practice problems. We just got to know these relationships. Everything's congruent unless they add up to 180. Corresponding alternate exterior, alternate interior, and vertical angles. They're all congruent. Linear pairs and same side interior add up to 180 degrees. Good little summary there. Good luck.